Hey guys, so in this video, I'm just going to go over lesson 7.4, and it's called Do Skittles or M&Ms Have More Orange Candies? Ideally, this was based off of my name and Mr. Gordon's name, but I believe that Skittles has a higher proportion of orange candies versus what Mr. Gordon thinks, which he thinks the opposite of me, of course. But you guys should have taken your sample already and dot all your dot plots, and then what this graph should be labeled as is the simulated sampling distribution of p hat sub 1 minus p hat sub 2. P hat sub 1 technically is the sample proportion of Skittles, and then p hat sub m is the sample proportion of M&Ms. So those are what these things technically represent. Okay, so in terms of each dot in general, each dot represents difference in proportion of Skittles and M&Ms from a simple random sample of 50 pieces in general. And then part 4 was just to describe what was going on in the dot plot. For the shape, center, and variability, all this information could be found on Staplet. Okay, and then it tells you stop, watch the video before you do the rest of the things, just to make sure that you guys are on track. So when you do a Google search, it actually reveals that 21.6% of Skittles are orange, and then 70% of M&Ms are orange. And they want you to try to describe the sampling distribution of these two samples individually, okay? We need to figure out individually what's the shape of Skittles and individually what's the shapes of M&M. But what we can do here is do something called large counts, because in general, in our heads, if we have a lot of Skittles, ideally everything should always be normal, and same with M&M. So if I were to do large counts, I would do large counts on Skittles itself, and I'm going to call Skittles P sub 1, and then I'm going to call the M&Ms to be P sub 2. So I'm just going to use the percentage that they gave us. So if I were to do large counts on these, I still have a sample size of 50. So I know my large counts rule is 50 times 0.216. Ideally should be greater than or equal to 10. And then I'm also going to do the opposite, where I'm going to do 1 minus and then figure out what that value is as well. Okay, so if you guys were to actually calculate this out, one of them is going to be 10.8, which is the top one, which we know is for sure greater than 10. And then also the bottom is also greater than 10, and we should have got 39.2. So for this shape, we know that this shape is going to be approximately normal. So when you guys do this, you guys will do the M&M side. I'm just going to do most of the Skittles side. Okay, so moving on to the mean of the Skittles. So to find the mean, we know that the mean is going to also equal to whatever our population is. So mu sub p hat should also equal to whatever our population of our Skittles is. So we know that that's 0.216. So therefore, I know that the mean of my p hat over here, sorry, I should put sub 1, sub 2, is going to be whatever my p-value for my second one is, which is 0.2. Okay, so pretty straightforward. And then lastly is standard deviation of p hat sub 1 is going to be my 0.216 multiplied by 1 minus 0.216 divided all by our sample size. So the value that I get out of there is 0.0582. Okay. Okay, and then for the M&M side, you guys can fill out the normal part. You guys can also fill out the standard deviation part. Okay, so now that we have more information, we can actually describe the difference between these two things. So in terms of shape, the only way to know what shape it really is to do large counts or to graph it out. And because we don't have any numbers, the only thing we can do is do large counts. So from above, I can see that large counts for Skittles is approximately, it works. So it's approximately normal. And then when you guys do large counts for M&M, it should also work. And that's also approximately normal. So for the shape, you need to check large counts for both. And if it works for both, then we know for sure that the difference between M&Ms and Skittles should also be approximately normal. So I'll put therefore approx normal. Okay, so if we were to have two variables and we were to subtract the two variables to find the mean, you guys should know that we just take the two means that we have and then just subtract them from each other. Okay, so just stuff that we've learned from last chapter, just kind of moving on to this chapter. And you guys can find the total, which should be fairly straightforward. All right, and then standard deviation, if we were to subtract standard deviation, just use the same formulas that we had. So you're going to square our standard deviation, add them together, and then also make sure you square root it, okay? This is what you guys should do. So make sure you square the value for both of them. And then square root, okay? Okay, so last but not least, it says that Ms. Vo and Mr. Gordon calculated a difference in proportions of 0.08 from their samples. Calculate the probability of getting this difference in proportions or higher. Okay, so we know that in general, the shape is approximately normal. So that gives me a huge hint as to, okay, I know I should use something that's approximately normal here. I should have a new mean now. To properly label this, I should label it like this based off of what they told me from above. And this mean should be 0.016. And then you should also get a standard deviation. So make sure you guys write down the standard deviation. So if I know the mean is 0.016, then 0.08 must be over here. And then this is me shading the proportion or greater. Okay. So now from there, just use z-scores and plug in everything that you know so far. So I know the x that I'm looking at is 0.08. My mean is 0.016, and then my standard deviation is whatever you guys calculate it to be. Or just use normal CDF, and then plug in the values for your lower bound, your upper bound, your mean, and then your standard deviation. Okay, so that will complete that problem. And then a more complex way to rewrite what we have here in the more proper format is going to be this crazy formula that I'm going to write down. So what we're technically doing for each and every single piece. So the whole x part of this piece, which is the 0.08, the way you get that is you take p hat sub 1 minus p hat sub 2. That's what they technically did to get this part of the formula. And then we're going to subtract that from both of our means being subtracted from each other. And then we're going to divide that by our technical standard deviation. So our technical standard deviation is this right here, actually. P1 minus this, or is P1 times 1 minus P1 over N, and then plus P2 times 1 minus P2 over N. Okay, so those are our technical formulas there. Okay, so hopefully this helps. Make sure that you guys look over this lesson. I've also posted the last lesson just so that you guys have focus on where to go. But hopefully